Genome technologies are currently able to identify the genetic variability of each person even before they are born, rapidly, with great accuracy, and at a low cost. We all know the genetic chip, common nowadays, enables to identify genetic defects in the embryo and to prevent the birth of children with different syndromes, including such that may lead to the birth of individuals with intellectual and developmental disability. An additional example of changes in treatment policy following research findings is the consumption of folic acid by pregnant women. Its consumption had led to reduction in certain syndromes. In Iceland, for instance, every pregnant woman undergoes genetic tests and abortions are performed to embryos detected with Down syndrome. These technical capabilities raise ethical questions. Are we allowed to sacrifice the life of a person in advance in order to relieve them, their family, and society of unneeded suffering and expenses? Is it allowed to terminate an embryo's life with a genetic syndrome? How is the abortion of the life of an embryo based on a genetic test any different from exterminating disabled individuals, as has been common practice thousands of years ago based on the consensus of theoreticians who lived during that period? Can we also prevent the birth of short children? Or perhaps it's better to prevent the birth of brown-eyed children? And what about children with a high risk for cancer or autism? Where's the line between technical capability and receiving a moral decision? In the medical field, there seems to be a steady progress in extension of the survival of individuals with intellectual and developmental disability that present complex health conditions. In the first chapter of the course, we mentioned phenylketonuria, a genetic disease that causes an accumulation of phenylalanine. This accumulation leads to severe neurological deficiencies, including cognitive functioning at the level of intellectual and developmental disability. In many countries worldwide nowadays, all newborns are tested immediately after birth, since early diagnosis of the disease allows efficient treatment and prevention of intellectual and developmental disability through the implementation of an appropriate diet. Another example are the implementation of advanced heart surgery technologies, which allow nowadays to perform complex heart surgeries that were not possible in the past. These surgeries extend the survivability of children with Down syndrome, improve the efficiency of their treatment and their quality of life. Current technologies also allow limited renewal of nerve cells in the brain. Stem cell research and cell repair have great potential for future curing of many neurological disorders such as epilepsy, neurodegeneration, and more. An additional research field that shows impressive chance of success is gene therapy. Gene therapy is developing all the time, and it will be approved as soon as its practical potential for repairing genetic defects becomes possible, for instance in the case of Rett syndrome or Fragile X syndrome. In summary, recent years have shown considerable increase in life expectancy of individuals with intellectual and developmental disability. Many researchers all over the world perform studies to cope with this population that lives longer today than ever before. New technologies are being developed every day. Some offer early diagnosis like the genetic chip, and some attempt to overcome existing disorders and to reduce their severity, like novel heart surgeries for children with Down syndrome. Additional solutions are diet that saves the children with phenylketonuria. There are also studies that look for a way to repair genetic defects by replacing the defective section in the newborn's DNA with intact ones. These studies are still at the stage of lab animal testing, but they're already marking the future.